Welcome to EDU World Space.
We want to combine two different lenses with different indexes of refraction together, in which the effective focal length of this combination is the same for two different wavelengths. How do we do that? Well, problem 4 noted that in problem 3, we should use the result, which I have highlighted here in a box, in which 1 over the effective focal length is equal to 1 over the focal length of the first lens plus 1 over the focal length of the second lens. Okay, so let's first note that since the effective focal lengths are equivalent across both wavelengths, we can simply do 1 divided by each. And now we note that we can just insert the result from problem 3 into both sides of the equal sign. Okay, so what do we get? Once we substitute in, we get 1 over f1 lambda 1 plus 1 over f2 lambda 1 is equal to 1 over f1 lambda 2 plus 1 over f2 lambda 2. Now we have to note the lensmaker equation, in which we have, and I'm going to put this in another box, 1 over the focal length for a certain wavelength is equal to 1 minus the index of refraction for that wavelength. And then we have 1 over one side the curvature of the lens plus 1 over the second side, the curvature of the second side of the lens, in which what I mean by curvature is the radius of curvature. And we are now going to, just to simplify, since it's pretty much treated as a constant, we're going to treat this region here as equal to S. Now let's insert the lensmaker equation in, and we get 1 minus N1 given the first wavelength, S1, and now repeat for all the other 1 over the focal lengths, inserting the correct labeling. So let's go ahead and send this over to this side and send this over to this side. And notice that the ones will cancel out. And now we'll get this once we regroup our terms. So now let's just rework the problem, setting the S's to one side and the index of refractions to the other. And now we have a relation in which we can note that the ratio in the change across the indexes of refractions across the two different wavelengths must equal the ratio in the strengths of these curvatures of these lenses. Okay, and as for part B, we can now see from this equation that we can argue, we can write out and argue that the ratio on the left-hand side is going to be constant. However, the ratio on the right-hand side is not necessarily assured to be constant for different trials of wavelength. And thus we can conclude that we can only find specific ratios in the change of the index of refraction across comparisons of wavelength, then this will just work for any combinations of wavelengths we want to use.